In 1944, Eric Williams proposed a controversial theory. The wealth extracted from the transatlantic slave trade was the primary engine financing the British Industrial Revolution. Proving this theory using aggregate national data is difficult. At the macroeconomic level, time series analysis is constantly confounded by overlapping variables like agricultural yields, population booms, and technological shifts. To bypass the noise of the national economy, researchers shifted the unit of analysis to the local level using highly granular records from the 1833 Slave Compensation Act. This map displays the geographic footprint of 1833 slaveholder compensation. The wealth clusters around trading hubs, Liverpool, Bristol, and London. A map of 1831 manufacturing employment reveals a near-perfect mirror. Early industrial jobs cluster around the exact same hubs. At the microgeographic level, slavery wealth and industrialization correlate, but correlation requires proof of actual causation. Did slavery wealth build local industry, or did rich industrial regions simply possess the capital to buy more slaves? This is the central obstacle of endogeneity. Solving this requires examining the baseline property wealth in these specific regions, long before Britain scaled its entry into the transatlantic slave trade. Researchers compiled historical property valuation data stretching all the way back to the 1086 Doomsday Book to establish a centuries-long economic baseline. This event study tracks property values over time. Prior to 1798, regions that became heavy slaveholding hubs show no significant economic advantage. Only after the transatlantic trade scales up do we see a massive upward trend in property values. To prove this later wealth directly caused the industrialization, economists must find an exogenous shock, an instrumental variable originating entirely outside the domestic economy. That instrument is random weather across the Atlantic during the Middle Passage. This is a logbook page from the CLIWOC database, which allowed researchers to extract granular historical wind conditions documented daily by merchant ships. Atmospheric pressure and wind vectors mathematically dictated the only optimal sailing paths. These random weather conditions strictly determined the duration of the voyage. By utilizing a cost surface informed by these wind patterns, economists can predict the documented sailing time of these voyages with an R-squared of 0.87. When harsh winds delayed a voyage, water rations ran out. In the crowded, inhumane conditions below deck, infectious diseases spread rapidly. The quantitative toll is precise. Just 10 extra days at sea resulted in a 2.3 percentage point increase in slave mortality. Mortality rates were dictated by the randomness of Atlantic winds. They are entirely isolated from a trader's pre-existing domestic wealth. 18th century slave voyages required massive upfront capital for ships, crew, and cargo. The primary return of that investment depended on the survival of the enslaved people. High mortality rates from weather delays translated directly into financial ruin for the investors. This chart plots continuation probabilities for slave traders. Investors who experienced above median mortality dropped out of the trade at significantly higher rates. Conversely, traders blessed by favorable winds accumulated compounding wealth, allowing them to successfully transition into permanent plantation slaveholders. Using genealogical records, economists mapped both the successful and bankrupt traders back to their precise ancestral homes in Britain. The ancestral geographies of the bankrupt traders failed to accumulate slaveholding wealth by 1833, solely because early weather delays forced them out of the market. The geographic distribution of 1833 slavery wealth is tied directly to random 18th century weather, providing the exogenous variation necessary to test the Williams hypothesis. To understand the macroeconomic mechanics, economists use a spatial specific factors model. In the domestic economy, agriculture is strictly tied to land, and manufacturing is strictly tied to capital. The colonial slave plantation acts as a highly lucrative offshore bucket for capital investment, bypassing domestic limits. Because enslaved people were treated as collateralized property, these investments yielded outsized returns. That wealth returns to Britain, expanding the domestic capital frontier and pouring into manufacturing. Because 19th century domestic investments declined steeply with distance, this returning capital accumulated locally around the slaveholders' ancestral estates. This capital influx forces a structural transformation. It pulls labor out of the land-constrained agricultural sector and drives it into the booming, capital-intensive mills. By offering an offshore, infinitely scalable investment, slavery broke the domestic Malthusian constraint and directly financed local industrial hubs. These charts show the microgeographic impact. In areas heavily exposed to the slave trade, agricultural employment falls, while cotton mills multiply, driving local incomes up by more than 40%. Nationally, slavery wealth injected the equivalent of a full decade of economic growth into the entire British economy. This influx created a stark distributional divide. Industrial capitalists experienced massive financial gains, while traditional agrarian wealth stagnated. Traditional domestic landlords actually lost aggregate income. The rapid reallocation of labor to manufacturing drew up wages and reduced the value of land. The Williams hypothesis is addressed not by looking at aggregate national trends, but by isolating exogenous variables at the microgeographic level. The geographic distribution of the British Industrial Revolution was determined by random ocean winds, human commodification, and the local influx of offshore capital.